So, welcome. Yes, today's another session where we'll be going into set division. Yes, in the last video, we look at how to rationalize sets. The reason why we were trying to rationalize sets is from the understanding that sets are numbers that are actually irrational. So we can easily work with them, or we can better work with them when they become a rational number like 2, 3, 4, so that in such a way that we no more have a set symbol inside the result that we get. So we had to use multiplication, so finding the conjugate. So if you multiply a set by its conjugate, you are going to have a whole number, or you are going to have a rational number. So we are trying to rationalize the set by multiplying it by its conjugate. But then simply we said in finding the conjugate, you just simply change the middle sign between the terms. If it is positive, it turns to negative. It turns to negative, it turns to positive. That's what we actually did last time in our previous video when we look at finding the conjugate of sets. Today we are going to get ourselves into doing set division. But for set division, right, we know that we have to divide a number by another one in generally in doing divisions. But do you know that because these numbers set you say they are irrational numbers, so we don't want to divide. We are not comfortable of dividing a number by a set because set is irrational. Irrational means like it's not rational. Yes. So we can't easily manipulate it. So when you are doing a division, right? At the numerator, the top of the fraction, right? Set can be there, but at the bottom we can divide because irrational division by irrational is something we are not comfortable with. So the denominator cannot be containing sets. So whenever the denominator contains a set, we try to find a way to rationalize the denominator and make sure it become rational. Then the division is possible. So that's what we are going to do. That's what the set division involves. So for the first step in set division is like we have to know how to rationalize a set, which is in the previous video, finding the conjugate. Now after you know how to do that, and come here to do the set division. In set division, what we are trying to do that we can divide a number by a rational number. Set is an irrational number. Sorry. So set is an irrational number. So whenever you are having a division and there is a set component at the denominator, what we have to do is that we have to make sure that that denominator is rationalized. We bring that denominator into a rational number so that the set is gone for us to now do the division. But the numerator or the top of the fraction is okay. Set can be there, but the denominator, we are not comfortable working with. We are not comfortable with dividing a number by an irrational number. So we try to use the rationalization method by simply just revising, finding the, how do you call it, rationalizing the denominator, which is something that is very important in set division. So let's look at this example. If you're having root 3 plus 1 all over 2, for this particular one, we are not going to do any set division here. Why? Because the denominator, which is 2, the 2 is already a rational number that we know already. It's a 2, so something is 2. So the denominator is free, like there's no set there. So this one is the same. We don't do anything much on this one. So if there's any simplification that needs to be done, then we just do the normal simplification, addition, expansion, and subtraction at the numerator alone. But for this particular question, we are not going to worry about the denominator simply because the denominator is already a whole number. It's already a rational number. So yes. But in the case where we have square root of 3 plus 1 all over square root of 2, then there is a problem. We cannot divide. The bottom is not a rational number like 2, 3, 4, 5. So the denominator cannot, this division, we are not comfortable with it. So what we have to do is that we have to rationalize the denominator. This is the denominator. What is at the bottom is what we call the denominator. So you have to rationalize the denominator. That's what you have to do in division first. So in set division, you have to check the denominator. Is the denominator having a set, an irrational number? If it is having, then try to rationalize the denominator first before you move ahead. Right? Now, let's look at a simple example that we know. If I have 2 over 3, we know that 2 over 3, do you agree that it is the same as 4 over 6? like fractions. That's how they work. It's the same as, let's say, 6/9 is the same, or is the same as 10/15. However you can think of it, right? Sets, fractions, they generally work like that. But how do we get from here to here? So for example, for this one, I just do 2/3, right? I try to double the numerator and the denominator. Double the numerator and the denominator. So when I double the numerator and the denominator also double it, what happens is that 2 times 2, that's 4, and then 2 times 3, that's 6. How did I get this one to this one? The same fraction. What do I have 2/3 multiplying. So what I mean, I just multiply them by the numerator by 3 and the denominator by 3 is equal to 6/9. Yeah. So when you are trying to expand or transform, find the other forms of the same fraction, what we do is that we need to make sure that we are multiplying the numerator and denominator by the same thing. So what I really wanted to do was just to multiply the denominator by 3. But if I do that, I'm going to lose the numbers, the fraction itself, the value of the actual fraction. So what I have to do is that if you had multiplied the denominator by 3, make sure that you also multiply the numerator by that number. It works for additions. It works for multiplications. It doesn't work for addition. You can say 2/4. Let me do 2/3. Then because you want to add 1 at the numerator, they have to do add 1 at the top. It's going to give you 3/4, which is not the same thing. It doesn't work for, but if you want to do multiplication, it's easier. So if you are multiplying the numerator, we usually do divisions actually by simplifying it. But in the case where we want to now expand the number, something like if you have 4/6, it will be like, 2 can go into the top one, 2 can go into this one, 3, then I have 2/3. So what you are simply doing, you are dividing the numerator and denominator by 2. But then what if you want to go back? Because you are doing the simplification for both steps. So if you are going back, you are multiplying by the top and the numerator by that number that we are having 4/6. That's all we do. That's one concept that we'll be using here. Yes. So in handling sets, right, what we will have to do is that we have to rationalize the denominator. So if we are rationalizing the denominator, what do we do? We have to make the denominator to become a rational number. Now, if you want the denominator to come to a rational number, we have to use its conjugate, right? We rationalized the sets in the previous video when we are doing the sets, the conjugate. So if you want to rationalize the denominator, which is a set number, you have to use its conjugate to multiply it. You have to bring another factor or another parenthesis to multiply this, as we explained in the same video. Here, the denominator is square root of 2. But if you want to rationalize it, we watch the first video that if it is just a single square root number here, it's just a square root of 2 multiplying by itself. That's what will give us. So if you do that, you are going to have square root of 2 times square root of 2 is going to give you simply 2. So if we are trying to multiply by its conjugate, the conjugate of this guy is just this. So if you are doing that, you are just going to multiply the denominator by its conjugate, square root of 2. But look at something. We are trying to rationalize the denominator by multiplying by its conjugate, right? We are doing some multiplication at the bottom. From what we just explained earlier, we said that before you can do that, you need to make sure that what you use to multiply the bottom is what you use to multiply the top. So for that reason, if you're multiplying the bottom by square root of 2, right, you need to multiply the top. The top is an expression square root of 3 plus 1. It's not a single number, so you have to close it in the bracket before you multiply by square root of 2. Yeah, simply put, that's what happens. So whatever you are doing for the bottom, whatever you are using to multiply the bottom, you do it for the top too. That's how fractions work generally. So it's not a unique something to set, but something that works for all fractions. So for that reason, we have to multiply the top too. So just remember that whenever you are trying to rationalize the denominator, because we want to the denominator contains a set. A set is an irrational number. So what we have to do is that we want to bring it to become a rational number. So when you have a rational number, then we can simply do the division. So we want to make it simple for us. So first, we have to rationalize the denominator if it is not rational. So we have to rationalize it. So in order to rationalize it, we have to find the conjugate of that denominator. When we find the conjugate of that denominator, you use it to multiply, as how we did in the previous video. So if you just rationalize the denominator, you're not going to have fine piece until what you're using to multiply the bottom. That's why you use the same thing to multiply the top to maintain balance. If you forget to do that, you are going to get it wrong, because fractions must all follow in a particular ratio. Yes, so that's basically what happened. So all put together, we are just simply saying that to find a fraction, right, to use set division, in set division you have to look at the denominator. If the denominator contains any set component, so let's say root 3, I'm using root at the top, so people think it's always the top. I can have 2 over square root of 2. Yeah, so what I do is that the denominator is a set, so I have to rationalize the denominator. To rationalize the denominator, I need to bring the conjugate of the denominator. The conjugate of root 2 is root 2. Watch the previous video to get that. I find how to find conjugate. We explained that very well. So the conjugate of root 2 is still root 2. So for that matter, we have to multiply. When we find the conjugate, we use the conjugate to multiply the number in order to rationalize it. So this is the root 2 where we have it originally, and we multiply it by the conjugate, which is itself root 2. Because we are adding a multiplication to the denominator, to maintain balance, we need to make sure that we multiply the top 2 by that number. So when we do that, at the end of the day, the top will become 2 root 2. Remember multiplication of sets. Yes, go and watch that video. If you have it, then the bottom, square root of 2 times square root of 2 is simply going to be 2. Now when you have that, now you then do your simplifications. When you do your simplification, these 2 divide these 2, go into that 2, then at the end of the day you have root 2. So root 2 is your final answer for what we have. So you see that now we are kind of free from the set being a denominator. Yeah, that's what we do in set division. Let me now use a more complex example where the denominator is not just a number, but shows simply put, what the book will always tell you is square root of 2 plus 1 all over square root of 2. What you do is that we just multiply both sides like this. Yeah, this is the conjugate, but because we want to maintain that balance, whatever conjugate you are bringing at the bottom to multiply the bottom, you bring the same to multiply the top. So at the end of the day, even if you simplify this by, you get back your original answer. So that's what actually happens. Then you just go ahead. So this is not a multiplying, so you have to make sure that it is in a square root of 2 plus 1 in a bracket multiplying this square root of 2 that we have introduced because of maintaining balance. But the denominator, we are bringing the root 2 because we want to make it rational. If the thing does not require rational, don't bring any conjugate, because the denominator should contain a set component before you can decide to rationalize it. If not, if it's just a whole number 2, 3, 4, 5, don't worry, you just like that, the denominator is free, so you can go ahead with your simple addition, subtraction, multiplication at the numerator. So if this, we just use our, so for the numerator, for the denominator, root 2 times root 2 is going to be 2. For the numerator, now we'll do our expansion. What the previous video, how we do the expansion. So this time is this will give you 2, and then this time is this will give you just root 2. So yeah, this what we have for this. You can leave it like this, or if you good in fractions, you know that this is the same as 2 over 2 plus root 2 over 2. So you just separate the numerator with each taking the same denominator. So at the end of the day, you have 1 plus root 2 over 2. Someone can go further and say, oh, this is the same as 1 plus 1 over 2 root 2. Yeah, by stopping here is the final answer is already here already. The rest is just simplification, and this simplification may be very useful with some of the questions where they ask you to write it in the form a plus b root c. So in this case, our a is 1, our b is half, and our c is equal to 2. Now we'll get that when we are doing the solving question series. But right now, for this series of things, we are trying to understand the concept and why we do this or that. So why we do rationalizing of denominators, because the denominator contains sets. If the denominator contains sets, and these sets are irrational numbers, so we need to make the denominator become rational, which is a number that we can easily handle in divisions, especially. So because division requires a denominator to be rational, what we do is that we have to make sure that the denominator becomes rational. In order to do that, we need to use something called the conjugate of the set. So finding the conjugate of the set is what we did in the previous video. So yeah, let's look at another example. So now let me use another simple example. Like let me use just 3 at the top. So at the top, so 3 over square root of 2 plus 1. Remember, so the denominator is containing a set element. Because it's containing a set element, then the denominator is not rational. So what do? We rationalize the denominator. That's what we do. What do? We rationalize the denominator. Why? Because the denominator contains an irrational number, or which is a set. A set is an irrational number. So if you do that, we are trying to rationalize the denominator before we proceed with simplification and trying to do the division. For set division, we cannot divide by irrational numbers, right? So we need to transform it to become, so that the denominator become rational, so that the numerator can be contain sets. All right, fine, we are fine with that. But the denominator, I beg, we need to make sure that is become rational first. When you become rational, then the rest of the simplification come with your own simple algebra. So now to rationalize the denominator, what do? Because this is a whole term, right? So we have to know that we have to multiply by finding the conjugate of this guy. We said it. So you need to multiply the numerator and denominator by that conjugate. And the conjugate of that, if you watch the previous video, is just root 2 minus 1. So I'm multiplying this one also coming to multiply. So what's happening? Plus is here, so you change it to minus. So that's how to find the conjugate. Watch the previous video to get that concept. Now in this one, then we have the top multiplying themselves, root 2 minus 1. We did expansions in multiplication and stuff. Then we have root 2 plus 1 multiplying root 2 minus 1 at the top. So you remember how we find the conjugate of sets, right? When we find the conjugate at the end of the day, when we have something like this, like a squared minus b squared, that we do. So a squared is the same as root 2 all squared minus the b is for 1 all squared. Then what do we have? We expand the top. For the top, there is just simple expansion 3. So now what do I have? Then the top is 3 root 2 minus 3. The denominator, root 2 squared is 2 minus 1 squared is 1. At the end of the day, the numerator have 3 root 2 minus 3 all over the numerator. 2 minus 1 is 1. At the end of the day, this is our final answer for this division. This is our final answer for the division. You see how rationalizing the denominator help us to quickly get our answer without any maybe worrying much. So we have to first do the rationalization. So rationalization, that's what simply we do in set division. Now I'm going to use another example where both the top and the denominator have sets. So let me quickly get you into that. Yeah, so let's see. So let me say 2 minus root 3 all over 2 minus root 3. Oh, 2 minus root 2. Yeah, this is okay. This is okay. So yeah, there's something coming from my head, so I'm not having to. Later you can solve questions from your textbooks, Akiola, Akron, or yeah, let's go. 2 minus root 3. Right? The denominator is having a set component. If you have another thing like 2 minus root 3 all over 7, this one, the denominator is not having any set. It is not having set. So the denominator is already rational. So there's no thing like go and be finding the numerator. We can have set over there. We are okay with that. There will be special cases that will be advanced, but right now is what you're concerned about. The denominator shouldn't be an irrational number, and it said it's an irrational number, so it doesn't have set. So 7 is, there is no set at the bottom for this particular one. So this one you don't need. If there is any simplification to be done at the top, I think the top is fine. There's nothing to be done here, so we are okay. By this case, for this particular example, we are seeing a set at the bottom. So in that case, you need to rationalize it. You have to rationalize. To rationalize it, what do we do? It's only the denominator. Please, the top, we don't go and be finding the conjugate of the top. We are concerned about the denominator. So what we are going to multiply it with is going to be the conjugate of only the denominator. Because the top also has said, and you have this pattern, so you may be thinking, oh, why shouldn't it be 2 plus root 3? No, we are concerned about the denominator because in division, right, we don't want to divide by any irrational number. We don't want that. So we are concerned about the bottom. So yeah, become 2 plus root 2, and the top be also 2 plus root 2, because yeah, that's what we said in the division. Then so when we have that, the top becomes 2 minus root 3, multiplying whatever we were bringing to the top to multiply it. The denominator, is they themselves, 2 minus root 2 multiplying 2 plus root 2. Yeah, so we have the conjugate multiplying at the bottom. So the top there we can easily expand by. For the bottom is going to be 2 squared minus b squared, right? A squared minus b squared, remember? So now for the top, what we do is we just expand. 2 times 2, I think that's 4. 2 times root 2, that's positive 2 root 2. And this one is going to be negative 2 root 3. And then negative, and then that will be negative root 6. Because we do the set division. So kindly go and look into that if you have forgotten. So the top is 4 plus 2 root 2 minus 2 root 3 minus root 6. That's the top. The numerator is 4. This one is going to give us 4. This one is going to give us 2. 4 minus 2 is just going to be 2. Simply 2. Yes. So if you look at the numerator, 4 plus 2 root 2. So I leave it like this because for them to interact, right? We said in addition, for them to interact, what should happen? The denominator, the roots should be the same. Now, this root is not the same as any one of them, as we explained. So go and watch back the addition. That's why I said you should watch the videos systematically, understand the concepts. If not, you might get confused when things begin to change. So never in your life, when you solve a particular question, I don't know which question you meet in future, whenever you solve any particular question, and then at the end of the day, you're having something like something at the top A, and you have a root something B plus C or something, anything you find. Whenever you find a root at the bottom, they won't tell you anything in those questions. They won't tell you. So you have to know that in mathematics, we cannot have a root at the bottom naturally like that. So what we have to do is that we just try to rationalize it. This rationalization, they won't tell you. Questions will not come later on that rationalize it. No, it may come for your WASI, but then it doesn't happen generally after that. Just to get the concept, get the feel. If you understand why you are doing it, there's no way you will forget it. So why we are doing that? Because we can divide by irrational numbers. We need to rationalize the denominator. Simply put, that's what this video is about. So yeah, for the division, we have to rationalize the denominator using the conjugate, and the conjugate that we use to multiply the denominator, remember to use it to multiply the numerator as well, in order to keep that balance, because fractions generally they want to keep that balance when you are making them equal. So to maintain that balance, if you are bringing the conjugate to multiply the denominator, make sure it also multiplies the ones at the top, and be careful, the rest is now your algebra. And kindly watch the videos that we've posted so far so that you can follow us. If not, when you jump into the middle of our videos and then we are using some terms, you may not get it. You may not understand why. So what we are trying to do is that to make you understand why this and that in mathematics. If you understand the whys of things in mathematics, it will be simple for you. So kindly follow us, like our videos, and then share it, subscribe, so that we keep you in the loop of the concept, so that you can build your mathematics thing and then ace your elective mathematics during your WASI. Thank you very much, and see you in the next video.